For this video, we're going to be working in Excel to compute our standard deviation and our root mean squared error. You'll notice that there's a lot of extra columns here. We don't really need most of these, so let's just go ahead and get rid of some of them, even these things we don't really need. I'll go ahead and leave the altitude just in case you want to mess with that. Now it's interesting to notice the h-stop is 0. Again, you don't want to rely upon the GPS for your estimate of accuracy. Let's go ahead and delete that. And delete those. Now I'll go ahead and leave the latitude and longitude and the identifications and the FIDs. The FID is added by Esri. The identification is probably what you used in your notes, so that's important. And lat long is good to look at. Okay, so we've got our eastings and our northings, and here's our corner of the grass for higher accuracy. First, to compute standard deviation. Standard deviation, we could go to the web and look up how to compute standard deviation. Okay. Oh, I don't even have to spell it correctly. And I tend to go to Wikipedia for a lot of statistics, and there's the calculation. So it's not too bad, and we could do it from there. However, you may be aware that Excel has a standard deviation. Now, here's a question. It has one for a population, entire population, and another one that includes standard deviation based on a sample. So those are actually two different ones. You want to ask the question, which one are we computing here? Well, since we've only got points that are around our corner of the grass, our benchmarks, I would go ahead and argue that this is based on the entire population. And those are slightly different, especially for a small number of points. Then we can go ahead and select our values. Notice I didn't select the corner of the grass. And there's our standard deviation, which, wow, is pretty high. So that would be our measure of precision, not accuracy, but precision. In other words, how repeatable our numbers are. And they do look pretty repeatable. Wow, that's really good. Okay, then we can do the same thing for our eastings. Oops, here we go. And in both cases, we've got an accuracy of well under a meter. Sorry, precision of well under a meter. That's pretty cool. So in other words, the GPS, if you do points over and over again, now I did these in a very short time period. If we did them over the course of the day, probably wouldn't be as good. Okay, but this is repeatability, so this is better than accuracy probably. All right, so now we need to compute RMSE. So if we go to the web, and we type in root mean squared error. First we, again, go to Wikipedia and we find out it's also called root mean squared deviation, as well as RMSE. RMSE is what I learned a while ago. And now it's being called RMSD. That's fine. Two different names for the same thing. And here's our equation. Notice our equation is very closely related to standard deviation. They're very similar. The big difference is instead of having a mean value, an average value, we're going to have our value of higher accuracy. So we need to take that value and subtract it from each of our samples. Now an easy thing to do in Excel, okay, is to say just y minus y prime. In other words, in this cell I'm going to put the northings, okay, from our higher accuracy minus that one, hit return. Now I can drag down, but that's not going to be correct because it's not going to lock into this value. To do that, I need to make each 5 be surrounded by dollar signs, and that just means that as I drag down, do not change that H5. So in other words, this one goes from H2, H3, H4, but H5 stays the same in each case. Then we can do the same thing for the eastings. Close that. I5 with a couple dollar signs. minus that, turn, and drag that down, and we find out, oh, okay, the difference is they're all off by about 2 meters, which makes sense. We shifted to the north and over to the west some. The order of this x minus x quote doesn't really matter, because the next thing we're going to do is we're going to take that and we are going to square it. Now I'm putting this in without an equals because this is just my notation to remember what I was doing. Okay, so good labels. And then here I'm going to go ahead and do this times this, return. So this cell value times itself. Drag down, and then I can drag over. Okay, so what I've done is computed the subtraction and then I've squared it. Now I need to sum them. So here I can do an equals sum these columns, close parentheses, and then go ahead and drag that over. Okay, and now I need to take those values and divide them by t. T is the number of samples we have. So this value is equal to that value divided by 3. This one is equal to that value divided by 3. Okay, and then last but not least, we take the square root. Now we take a look at this math. You know, you'll notice that it's like we're subtracting. So we're basically finding the difference between our sample and our higher accuracy coordinate. We're squaring it. That's going to make big differences even bigger and small differences less than 1 smaller. Okay, so it's going to accentuate the differences. Then we're going to sum them and divide by t. So we're kind of finding the average square difference. Then we're going to take the square root, which will bring it back towards an approximation of what our error is. Okay, so now we need to take square root. There's the square root, 7, turn. Okay, and we drag that over there. So about 2.6, 2.4 meters. Now I did this in both the x and the y. You could do this as a measure directly from the point to the other points at distance, but it's easier to do it this way, and this is fine. We now know that there's our RMSE. Okay, so that's our measure of accuracy, and that's our standard deviation, which is our measure of precision. So those are what would go into our report. And I would definitely save this Excel file. Right now it's a CSV, so we needed to go ahead and do a save as, browse, and save that as an Excel workbook so that we have it for later, especially if we want to combine all the classes data together. Have fun.